Welcome to AI Builder Lab. This first video is deliberately small. We're not starting with theory. You're going to understand what an agent actually is by walking through one real example. The example is a roulette agent. It listens to what a customer says, uses a Python tool to check the winning number, and returns a typed answer, true or false. That's it. Nice and simple. By the end of this, agents should feel a lot less mysterious, more like normal software, just with a large language model sitting in the middle. Most people start with a large language model as prompt in, answer out. That's useful, but it's limited. An agent adds structure around the model. It gives the model a job. It gives it tools it's allowed to use. It gives it the context it needs at runtime, and it asks for a predictable output. The agent isn't magic. It's a normal software boundary. The large language model makes a decision. Your Python code does the reliable work, and the final answer comes back in exactly the shape you asked for. That's really all it is. There are 4 moving parts to keep in mind. Let's go through them one at a time. First, the instruction. This is what you're telling the agent to do, its job description. Second, the tools. These are real Python functions the model is allowed to call. Not everything, just the ones you give it access to. Third, the context. This is private runtime data your code passes in. In this example, that's the winning number. And fourth, the output. What shape should the answer take? Here, it's a simple Boolean, true or false. Once you can spot those 4 parts, most agent examples become a lot easier to read. You're not looking at magic, you're looking at a clear contract. Here's the whole example. Don't try to understand every line at once. Split it into 3 sections. First, you create the agent and define its contract. Second, you register a Python function as a tool. Third, you run the agent twice, with 2 different user phrases. The winning number is 18. So one run should return true and the other should return false. That's the whole story of this file. Keep that in mind as you walk through it. The first key idea is that the agent is a contract. You choose the model, you declare the dependency type, you declare the output type, and you give it a system prompt. Think of it like defining the rules before anything runs. The model name tells the agent which model does the reasoning. The dependency type says the private data you'll pass at runtime is an integer. The output type says you want a Boolean back. Not a paragraph, just true or false. And the system prompt tells the model to use the roulette wheel function to check whether the customer won. So before any code runs, you've already described exactly what goes in and what comes out. That's the contract. Deps is short for dependencies, but the easiest way to think about it is private runtime context. It's data that belongs to your application, not to the user. In this example, the user says a number, but the winning number, that belongs to the app. You don't put it in the user message. You pass it separately, using deps. And that distinction really matters. Real agents often need access to things the user should never see. A user ID, a database connection, a config value, or an internal business rule. Deps is how you pass that information in safely. It keeps private data private. Now let's look at how the tool actually gets that hidden number. This is where RunContext comes in. RunContext is the bridge between your agent run and your tool. When the tool runs, it receives a parameter called ctx, and inside ctx you can access ctx.deps. Because the agent was defined with a deps type event, the context is typed as RunContext event. That keeps everything clean and predictable. Here's why that matters. The roulette wheel tool needs to know the winning number, but the model doesn't get to see it directly. Instead, the Python function reads it safely through context. The app passes the number in. The tool picks it up through cx.deps, and the model never needs to know it existed. The decorator is what turns a normal Python function into a tool. That's the most important idea here. A tool isn't a prompt. It's your actual code. The model can decide to use it, but the logic lives entirely in Python. In this case, the logic is simple. You compare the square the customer chose with ctx.deps. If it matches, you return winner. If it doesn't, you return loser. But here's what's worth pausing on. In a real product, this tool could do almost anything. Query a database, call an external API, run a calculation, even generate a document. The model handles the conversation. Your Python handles the work. That separation is what makes this pattern so powerful. When the user says, "Put my money on square 18, the agent doesn't read those words literally. It understands that square 18 means the number 18, so it calls the roulette wheel tool with that value. The tool then compares that number with what's stored in ctx.deps, which is also 18. They match, so the tool returns winner. Now here's the part worth paying attention to. The agent delivers the final result as a Boolean, true or false. The model handles the language, the tool handles the truth, and the output type keeps everything consistent and predictable. Each piece is doing exactly one job, and that's what makes this pattern so clean. The two outputs here tell the whole story. The winning number is 18. So when you say square 18, the tool comes back with winner, and the typed output is true. When you say 5, the tool returns loser, and the typed output is false. Simple, clean, and completely predictable. Now notice what didn't happen here. The model wasn't asked to guess. It wasn't asked to reason its way to an answer from nothing. It was given a tool, it was given context, and it returned a Boolean. That's the whole point. The model handles the language. The tool handles the truth. So let's bring it all together. Here's the core idea to take away from this. An agent is a software boundary. It combines 4 things: a model, tools, context, and a typed output. Each one has a job. The model handles language and judgment. Your tools handle business logic, data, APIs, calculations, and typed outputs make the result predictable for the rest of your app. That's the pattern. And that's exactly why this roulette example is so useful. It's not about roulette. It's about showing you a structure you'll reuse again and again in much more serious products. Keep that pattern in mind. It's going to show up everywhere. To make this stick, don't just watch the code, actually change it. Try setting the success number to 7. Add a validation tool that handles invalid roulette numbers, and experiment with returning a richer object instead of a plain Boolean. Most importantly, pause and ask yourself, why does the winning number belong in deps and not inside the user prompt? That question is worth sitting with. It gets at something fundamental about how agents are structured. In the next video, you'll go deeper into running agents. That's where things get genuinely interesting.